Welcome back to the shop, guys. If you enjoy machining, this video is for you. Get comfortable. This is an hour long. By the title, you can tell it's making an adapter for the universal tool cutter grinder, aka D-bit grinder. Forgot what I was going to say. Well, in any case, I hope you enjoy the video. Make absolutely sure, though, you do watch the very ending of it, where I give a in summary. There's some pretty good advice or something that I've learned here. So enjoy the video and see you again soon. Like I said in the past video, these little guys, the 100 centimeter wheels with the 20mm bore on them, hole back here, are everywhere. This is a diamond wheel, ran $20. I just found on Amazon an aluminum oxide wheel, 20mm hole, $11 prime. So the decision is I can either buy these wheels and bore them all out for 1 1/4 inches, or I can go through the painstaking process of trying to make an adapter, which this one is. What is this wheel? This is Diamond CBN 200 grit cubic boron nitride. And if you want to take high-speed steel down, this takes it down really quick. Drill bits, as you can see. I'm not even going to get into that yet. That's a nightmare in my opinion. But a drill bit just goes right into it and disappears. No heat, doesn't turn blue. So I decided here, obviously, to try to make an adapter. The problem was I couldn't figure out how to make it in one piece. In other words, never take it out of the chuck, so I know it's absolutely true. So this one, I wound up chucking it this way and turn down this face, turn this down, turn this, threaded it. eBay had the threading die for here, 8mm. At $10, and it also had the tap to make this nut, another 10. So I'm in it like $20 for tools, but and Touch TRO did a nice job in the whole circle function. That was great. So you can see I kind of added some material as I built this thing to the print. Pretty confident that the print is correct. Once I had this whole side done, I did take it out of the chuck, because now I got to do this taper here and put it in my four-jaw. And the four-jaw is, it was bought a long time ago from LMS. Yep, constant problems with it. They were sending me replacement jaws because they were all crooked. I mean, it was just a mess, and I gave up and said, all right, fine, just work with it. So using the four jaw, it was very difficult to try to get this so it's not this way and it doesn't have run out. Best I could do was like a couple of thousandths this way, and I think it was a thou worth of wobble. When I actually put this on the machine, I've got 3 thousandths this way, and I didn't check the other face. But it runs nicely, minimal vibration, so great. So, like I said, I can either, bore out all these wheels or spend the time to do this. Since this guy was pretty successful, I kept thinking, how can I do it in one piece? And I can't flip this over. And I finally came up with the idea. What I'm going to do is going to waste quite a bit of nice 2-inch material, but I plan on cutting this, not here, my part, this is going to be the material for the part, but I want extra here to go into the chuck, the 3-jaw chuck. So I'll cut it here, and then I'm going to turn this section down to smaller than this dimension. So what's going to happen now, if that's down, that piece goes into the chuck. So I'm actually have some clearance here. You know, the chuck would be about here. So now I can face this. I can turn the entire thing down. Now I can come down in and I'll have some clearance because I'm going to use the power feed. And I'll have room here where I can stop the power feed before hitting the 3-jaw chuck. I can take it down here. I can take this down. You know, it's all in one piece, never comes out of the chuck, so I know everything is perfect, no run out, nothing. Then I can drill all the way through, bore the taper in here, and everything, and then part it off when I'm done. And then that little piece that's still in the chuck, it goes in the scrap drawer. So, hopefully it's successful. It's the first time I've ever done anything this way. So let's go over to the bandsaw and cut this guy off. Alright, over here at the lathe. And the magnets are working out pretty good for balancing. They're not too critical. I still haven't really stuck them down, but, and I've moved them a couple of times. It's not that critical where they go. And you can see the compound is still angled from making that last trial run adapter. But I was setting this angle to this edge, and it dawned on me, maybe this edge is not parallel to the face. So I had taken the jaws out, and I checked this angle to the face of the chuck, and sure enough, it's right on the money, at least something less than a tenth. So I'm all marked out here. There's the part. Okay, get him in there. See if I can get it kind of straight so it's not wobbling a whole lot. Hey, that's pretty good, Dave. Yeah, that is. Alright, lock it down real good, because like I said, it's not going to come out until I'm completely done. Oh, actually, no, I'm going to be spinning it around here, right? Part. Yeah, I'm putting it in there backwards. I gotta put the part in first. This guy goes in there, because this is what's going to be permanent. Watch, I won't be so lucky holding it straight. Hey, I'm lucky again. Alright. Right? Yeah, that's not really moving around. Alright, so lock it down pretty good. And what I'm going to do is this. Look at this. There. Alright, so bring my writing up. So this was the extra, and this was the gap for clearance, and then this is the jaws. So I got to take this part all down to smaller than that thread dimension. Then I can flip it around, and that's a lot of material to take off, so I'm not about to use my good cutter. Where is the, here it is. Just a regular cheapo guy that I beat to death, and he still keeps cranking. He does not want to die. Wow, why am I that far out, huh? Sheesh. I'm almost all the way back here on the cross slide. Hey, move it all the way over. So it's got to be right in there. Like, this doesn't really matter that much because the finish is not that critical. Put my stop in place. Goes down here to here. And the line is right there, huh? Close enough for government work. Set him in place. Make sure he locks down really good. There, that's nice and tight, right? Good, it's not moving. Engage the power feed, and I should be good to go. Yeah, I can always move over further. That's close enough, though. Right, part, jaws on all the free clearance. That's quite a bit to be hanging out. Well, that's it. I'm down to 650 thousandths. Cleaned the machine up a little bit because it was a total wreck. So now it's time to spin it around. Boy, I gotta, yeesh, man, these things are a mess. That's gotta be taken apart and cleaned. Just stick it over there. Everything's a mess. I'm gonna take some compressed air to this thing first, but because this outer part here is going to be the threads for the nut, so I'll be able to clear that. It has to go down to 700. Yeah, it's a little warm from all that work. Change the wow, change the jaws out because now it's small enough that I can actually hold it in the other set of jaws. Come on out. These got to be cleaned up too. Number 1. Yeah, have it all memorized because of that sticker. 1, 2, and 3. Is it clean in there? Yeah, it looks like nothing got in there. Nice. Where's the other jaws? Here's number 1. Kind of the cool thing is it doesn't matter what slot they go in. They just need to be in order. So I can go 1, 2, 3 or 1, 2, 3. Any which way I want. That's number 1. Here's 2. So I should have plenty of clearance because the other jaws are hanging out farther. And jaw number 3. Alright, perfect. These gotta go. Yeah, I'll have lots of room. So I think, yeah, I did say I wanted 3 jaws to grab it. So, and then the first thing I'm going to do is take the entire out. Well, I'm going to face it. There's 3 jaws, right? Yep. How bad is it? Nah, it's not too bad. Face it. Put my good tool in there for aluminum. Where are you? Here you are. Angle's still good. Ooh, that moved. Don't need this now. So he goes for a while. It's not a very steep angle, but that should work. And take it down to the main diameter. Let's see here. Oh, I still have power feet engaged. Take that off. Do I hear gears? No, good. No gears. Yeesh. Well, they did a pretty bad crooked cut here coming out, huh? Downloaded some of the footage. Move the camera here a little bit. Watched it and realized the glare from outside is pretty bad, so I closed the door and used just the overhead lights. Pretty cool. Print said I was. Where's the print here? I'm going to need it here in a second anyway. Alright. Said I needed to turn this, which is this outside part, to 1 inch 930 thousandths. Did that. Turned the whole thing. Sanded that a little bit nicer. Just touch it up. Touched up this little section, which isn't that hot, but. So now it's time to completely switch everything around for going the inside over. Now, this is the first time I've ever put the saddle stop on the other side. Oh, nice. I can't go back far enough, huh? Ooh, boy, this is going to be a problem. Even if I shorten it, how much do I have to go in? Let me see here. Always a problem, huh? Take this guy. Oh no, it's that. So I gotta move this in. So there's nothing else I can do here. This is the only way to do it. I gotta go in what? Does it say? Oh yeah, because it's now 20 millimeters. The print is the 1 1/4. I gotta go into 787. Which, alright, I have to get a calculator here, figure out just if I can do this. I better be able to. Wow. Because if I go, I'm all the way back. If I go to here, yeah, I want a little bit more. I gotta use that angle, if not straight. So take it, so it's not quite touching. gotta see how far that's gonna let me go in. Oh yeah, okay, so I can always go so much, and then I can move the cutter out. Oh, genius, brainstorm. Alright, so I'm not touching, and the saddle stop's gonna come back, and it's a mess. Brush, clean some of this stuff off in there. Alright, cool. First time this side. Wow. It's not loose. There we go. Perfect. And I need to, what is that supposed to be? 235 thousandths. So I want what extra? I want 50 thou extra. So alright, where are you? 235, 285. I want 2.285. There. So I want to put the cut over there. And he goes up against it. I'm just going to tilt the lock on this bed. There it is. Perfect. Alright. So, perfect. I'm there. Right? I'm there. Oh, power feed's got to go in. Okay. And I have plenty of room. Ooh, do I? Yeah, I'm safe to stop. Here we go, huh? This will be interesting. Make sure the power feed's going to go in the right direction. Huh? There. Not moving. There it goes. Alright, so. Is it really in the notch? Yeah, it is. Okay, first cut. Here we go, huh? And it's cutting it. Cool. So I gotta figure out how far I gotta go in, which is gonna be a long way. Oh, well, I'm just gonna keep calipering what's a little faster here. A little cutting fluid. Oh, this is my good. I need to put a junk guy in here. Right. So I am 40 thousandths from final. And I did stop and take the cutter and move it out further so I could get in there, because I was going to start this hitting this. So I'm going to clean this complete mess up that you see, so I can be set up here for the final stuff. Go to my nice aluminum cutter, and somehow I got to figure out, I think I'm just going to angle it like crazy and then come in. So I'll bring you back for the rest. Well, sorry, battery, is this better off? Probably. Battery went dead, takes 2.5 hours to charge it, and I really wanted to keep going on this thing. So I've got this to thickness now, to the print. This guy, I've measured a lot of the wheels, and they're all oversized by a bit. So I am a half a thou under 20 millimeters. So 0.7865. This guy's turned down. It's ready for threading on here. Broke these edges a bit. So I want to come in, and once I'm done with this boring, relieve this for threading. So I use the parting tool or whatever. The original one, first one I made, I did 84.1. The math says it's supposed to be 84.4, so I'm gonna take a chance. I'm at 0.4, and I'm doing it with this guy here. He just simply goes against this edge here and right up against the work, which is clean. Boom, there I am, 84.4. And I did check this surface here against the face of the chuck, and they are right on the money, so I'm lucky being parallel that way. I'm not going to show a whole lot of this boring, but oh yeah, this was drilled all the way through to here, getting ready to tap this end with the 8mm, then a 10mm end mill was run in there to create that flat face down here. So, and that went in 830. So I'm set. Now it's just a matter of doing this taper, and I'm not going to show all of it because I really need to pay attention to what I'm doing here. Alright, so what's in there? I don't know, why does it seem like there's an edge in there? Well, let's see. Alright, bring it on up, man. Here goes nothing, huh? All this hour. This is day 3, too, of doing this. Well, hit already, will you? There we go. So, it's not really that complicated to do. It's just take your time, do a nice finish. Tool's cutting really nice. As you can see, I'll be putting some fluid in there as I get closer. Okay, it's cleaned up, cut off, faced off. I decided to go a little bit deeper with the relief here. This would be the first time. I'm not sure if the camera can see the counter bore. This is the 6mm, and I didn't have to touch the tip because it just goes right in there. So I got my DRO on here. Take it in till it just touches and zero it out. Zero. Because I gotta go in 200 thousandths. I don't know how this is gonna work, but we'll see. Go slow RPM, huh? Looking at it. Yeah, it's doing it nice. Beautiful. Look at this. Oh, this couldn't get better. What am I at? Nothing yet. Wow, that is nice. There we go, 10.1. And I gotta go, oh, that's 0.2. That's not 200 thousandths, that's 20 thousandths. Okay, so I gotta go in a ways. Oh, this is nice. Very nice. What am I at? 4, 5, 6, 7. Lots of nice chips coming out. 8, 9, 100 thousandths. 1, 1. Yeah, it's a mess over there. 2, 3. Actually, I think I'm going to quit at 9. 4, 5, 6, 7, 8, 9. Tell you, at this stage of the game, you double check everything. You read the tap. Is it truly an 8/125 tap? Yes. Alright, so this, if I remember right, isn't too bad. I'm using plenty of the cutting fluid on it, but just go slow in there. And it's going in there nice and easy right now. So, but it's not really to the big part of the threads yet. Actually, the first one, I used a drill bit that was in the drawer, and it was just a little bit smaller than it should have been. I looked up on the internet what I was supposed to use as far as a fractional, and turns out it's bigger, like a few thou, but yeah, this is going pretty nice. Take it out, clear the chips, or just keep going. That's getting tough. I'm gonna clear it. I don't want messed up threads here, you know. Alright, relieve this guy. And back it out by hand. Yeah, it comes out. But I'm using that aluminum tapping fluid. And that stuff, like I said, the chips are completely different. Wow, look at that, plugged up. Air, clean it off. Alright, and the fluid, I don't want this sucker drowned. Oh, these threads look gorgeous in there. Alright, I want it all over these threads. There we go. Stick them back in there. pressure back on it. Hold it dead center. Ah. Eesh. There. Put a little bit more push on it. And this should be the final then. Yep, there it hit. Just a matter of taking your time. Oh, dropped it. Still junk all over the place. I haven't cleaned it up yet. Yeah, it's pretty tough. Ow! Yeah, it is. This one is not fun because you can see the size of this die here. And the problem is I'm trying to keep it straight. I need somebody to put pressure on the back of the tailstock, and to actually turn it I gotta use a crescent wrench, or monkey wrench. So this one's kind of not fun and takes quite a while to do, so I'm gonna wind up doing it off camera because you gotta go a fraction, back it up, fraction, back it up. Cannot tell you just how much unfun that is. And you can see I had to replace the paper because it did give out and slide, but that's it. I got it all the way down now. Yeah, boy. It's threaded all the way. That should do it. I had to take a couple of thousandths off of it. It was just getting too hard to do. There. Clean the threads up a little bit, reverse on, and get it in there. Oh yeah, they're a wreck. Too fast. Wobbling around a bit. Yeah, they're soaking with this cutting fluid. Slow that down more. There we go. Now I'm getting it out. So that's basically it, man. Do have to clean that up, but the nut should go right on there. I might want to clean this edge up a little bit too. Where's the nut? There it is. Put the mic down for a second. Alright, I'm back. Did you miss me? No. Alright, so this should go on. Come on, get on there. Yep, there we go. All the way down. Beautiful. Works. That doesn't look too bad. That's not wobbling. Yeah, it wobbles a little bit, but there's enough of play in the threads that should work fine. So this be done other than cleaning that up. Turn it around. The inside's fine. I just got to do a little bit of cleanup here and I'll be done. Alright, pretty good success. I guess first up, this is the $11 wheel from Amazon. Came in, it's meant for high-speed steel, 5,730 RPM, 80 grit. Not as great. The edges are kind of a mess. Inside too, but I'll dress this off. That is an oversized hole. This is the first one that I made, so this one's going to be dedicated to this wheel because since this wobbles, or not wobbles, has a little bit of run out, I can center this wheel up and leave that dedicated to it. So that's done. This guy is the one you just saw making. Well, that was a pain. Did try it on the machine and it fits perfect. So 84.3 degrees works. This one I'm going to dedicate to all these steel kind of wheels since I haven't checked the run out, but it fits, I mean, right on that sucker too. So yeah, you can see just, you know, got to jiggle it to get it in and out. So I got to make another spacer, which I'll do for both of these, and another nut, but I had to make my own little felt guys here. So this works great. I already had it on that wheel and it clamps right down on it. So I'm done with this guy. Consider this project a success. The extraction tool goes in there perfectly. I mean, it works nicely. Yeah, the screw too that clamps this whole thing on the spindle works. Oh, I haven't cleaned this edge up yet, so I got to change the jaws out so I can clamp this and just resand that surface. So this should have 0 run out and 0 wobble since it was all done in one piece. So I think I'm the only one on this planet with a Shars machine that takes 1 1/4 inch grinding wheels, now takes 20mm wheels. So if you guys want to dive into it, have at it. In closing, this is the second one. This is the one you saw being made. I didn't show doing the nut part here and the spacer and things, so because I think just the body is mainly the hard part to do, and he came out perfect. And before everybody climbs on me about aluminum, I talked to an engineer at Norton Abrasives, and he said, yeah, for the size of this wheel, this is fine. When you get up to around 20-inch wheels, you may want to consider steel because of the thermal expansion. And also, there's not going to be wear because this is going to go on the wheel and it stays there. It's not coming off once I have it balanced and run out down, so dressed off. So bottom line, if you buy the U2, you're going to get the adapter that goes for 20mm. You cannot find, I cannot find these adapters anyplace. So you will be, just like Stefan Gothwenter, making your own adapters. And I'm not sure if you buy the 1 1/4 inch adapter from Shars, whether it fits the U2. And the U2, you're also going to be running, I think it was 3,400 RPM. If you buy the Shars machine, you'll be running at 5,000 RPM, and you can buy extra 1 1/4 bore adapters. And then if you want to go for 20mm like me, you make your own. I'm close enough with the print, I can release it. If anybody's interested in the dimensions here, they're working. Still not 100% sure about this taper here. I'm looking at taper reamers and stuff, but that's another project. A couple things to note, these wheels do not come with the blotters. So I had bought a paper cutter a long time ago to make my own blotters. You can see it's on this wheel, both sides of it. So that's important. You talk to Norton Abrasives and they explain. Oh yeah, Norton Abrasives has their own YouTube channel. Go and watch the stuff. They actually explain why you need these things on your wheels. So there's that. All the off-the-shelf store-bought ones do not have surfaces ground like this. They also explain in one of their videos why you need this surface like this. So I've been cutting, you can see it here on all of it. I probably should put it on this, but I'm not going to. And I've done it to these spacers and things like that, and had to cut my own little felt thing. So for now, I'm set. I've got a pretty good assortment of wheels. I've got some adapters for different wheels. So now I'm going to get into actually doing some different tools and things. So hope you enjoyed the video.